print line colon. Now I haven't changed my program at all. I'm just trying to figure out what's going on here. So I'll save that and I'm going to run it. And we've got a lot of stuff and it's still working. It reads a line. It reads a line, splits it into words, and then prints out Saturday, which is the third word on the line. Now here it reads a line, and this line is a blank line. And it has, because it's a blank line, the split returns no words, and that's what blows up. And the problem now is, oh wait a sec, list index out of range. So word sub 0 is not valid, which is the first word, when there are no words. So this is a statement that works most of the time. Now you might think, oh, I want to just put a try and except in there. Well, the right thing to do is to say to yourself, oh, wait a second. If I don't have enough words, if the length of the words is less than 1, continue. So basically it's going to come through here, it's going to split it, and if we don't have any words, meaning it's a blank line, then we're going to skip it. So let's run that. So now this ran all the way to the end. It did a lot of stuff, and it did not blow up specifically, didn't have a traceback. Another way to protect this would be to, we'll take this part out. This is called a guardian pattern. Right, guardian pattern, because this is dangerous. This could blow up, but it won't blow up if it makes it past here, and it won't come through there under the conditions that are causing it to blow up. Another way to do this might be to protect it as follows: to say, oh wait a sec, if the line is a blank line, no, continue. So now what we're going to do is we're going to skip blank lines. I even say this: print skip blank. So if it's a blank, we're going to skip blank and keep going. This will skip blank lines. It'll come through here, and this will skip lines that don't have from. But because we're not processing blank lines, word sub 0 always works. So I can run this code, and it works again. So here we have a blank line, we skipped it. Here we have a blank line, we skipped it. Now here we had a non-blank line, so we parsed it, but then we ignored it. And then up here we'll find a from somewhere. Doo-doo-doo-doo-doo. Let's find a from. Here it comes. Oh, no, there's ignore, ignore. I got too much debug print. I can't find it. Here, I'll just hunt for from with find. Okay, so there we go. There's from, and we print the thing out. So we're getting a lot of extra stuff. So I'm gonna comment out some of these debugs, and I'm actually just going to get rid of this whole skipping of the blank line. I'm going to do it with the words. I'm going to go back to the guardian we had before. If the number of words that we got, len of words, is less than 1, continue. Okay, so now this is going to be a working program. Oops. I gotta take another print statement out. Gotta take another print statement out. We sort of know what we're doing here. Okay, so this looks like a pretty safe thing. This guardian is protecting this dangerous. I get rid of that one too. This is the words that are traced back, and nothing else in this thing changed from when we started, except we've added this little guardian. Now the interesting thing is, if it comes through here and prints word sub 2, what happens if somehow we find a line that has from as its first word, and there's only one word on? This is going to blow up. So we can make our guardian a little stronger. And we can say, you know what? We're gonna skip this line if it doesn't have 3 words in it. So it has to have at least 3 words. And if we see less than 3 words, we're going to skip it. And that just makes the Guardian a bit stronger. And so the program works safely, and you see these things where sometimes you want to check to see that your assumptions about the data are reasonable, and skip things where the data is not reasonable. Now, so that's one Guardian pattern. Let me show you a slightly different way to do this, and this is with an OR statement. So I'm going to take this code, copy that, and put it here with OR. Get rid of all this stuff. Well, this is the Guardian in a compound statement. So what we're saying is if there are less than 3 words on the line, or if the first word is not from, continue. Now, we're doing this in order because the way it works is OR is true if either that's true or this is true, but if it knows that this is true, then it doesn't bother checking this. And the checking of this is what blows up, what causes the traceback. So if we flip this order, it would fail. If we do it in this order, it will work. So let's do this one right. It works. But if I get this backwards, it's going to check this before it checks this. And we're going to go back to failing again. So you got to get the order of these things right. The Guardian comes before in the OR. The Guardian comes before. And if this is true, then it doesn't check this. This is called short circuit evaluation, where it knows that as long as this part's true, it doesn't evaluate this second part. And so now we have a Guardian in a compound statement. You'll see this a lot. Sometimes if it's more complex, you do it in multiple statements, or you fall through, check for sanity, and only run the code. So I hope that was useful to you, looking a little bit about how to debug where you don't just start chopping on the line that had the problem. It's not always that line, because we never did change that line. Although we did change it a little bit at the end. We added this Guardian here, but we also fixed it without it. Sometimes you add some print statements to figure out what's going on before you just start chopping on that line. So again, I hope this helps. Thanks.
Hello and welcome to Chapter 9. Now we're going to talk about Python dictionaries. Python dictionaries are probably the thing that most programmers love the most about Python because they're very powerful. They're like a little in-memory database. It's the second of our kinds of collections and probably the best collection. To review what a collection is, it is a situation where we are going to have a variable, like a list or a dictionary, that we can put multiple pieces of information in rather than a single piece of information. And of course, prior to collections, we would put something into X and then we would put something else into X and it would be overwritten. And now with lists, we can append things onto the end. And so if we compare lists and dictionaries, the list is sort of the organized version of the collections. Everything stays in order. You add something, it always adds to the end. You take something, it sort of compacts itself. It's 0 through the n-1, where n is the number of items. And so it's very organized, kind of like a Pringles, where the potato chips are nicely stacked. Dictionaries are messier. You can put things into dictionaries. There's no real sense of order in dictionaries. Everything has a key, so you sort of throw things in and they kind of mix around in there somehow, and you pull things out based on the key. It's like you sort of stick a label on it, where you say, okay, I'm going to take this thing and I'm going to put Chuck on it, and I'm going to take these sunglasses with the Chuck label, and I'm going to throw it into the dictionary, and I'm like, hey, give me back Chuck. I'm like, oh, here's your sunglasses, because you mark everything. This is like the key. This is the value. I took a pair of sunglasses and I threw it in. So it's kind of like a purse, or it's a sort of like a mess. And so the idea is you have these labels that you put on everything that you're going to throw in. Like I'm going to put, hope it won't stick to my keys. What else do I got here? I'm going to stick a label on my pen.